Okay, suppose we want to develop our ROC curve for this node, okay, where we transform the departure time into 17 bins, and we did data partition 60/40. Okay. So you've already run the node, so we have the results already generated. You go to the validate data set, okay, from exported data. Okay. So and then do browse. At this point, we can export it to Excel in that fashion. Now what we need are the actual class and predicted class and the propensity. Okay, so okay, so here we need the predicted class, okay, and this is the predicted class and this is the original class and this is the propensity. Okay, let's look at the data that we exported from SAS. So here, okay, so predicted status delayed. So what we see here is the probability, and this is on time. We are not interested in on time, we are interested in delay. Okay, so this is the probability or propensity for event equal to delay. We want that, and we also want what the original flight status was. So this is into flight status, so that's our predicted value, and this is from flight status, so that is the actual. This is actual, this is predicted. So what we want is, we don't want this, so we want these three columns. And this is, remember, for validation set. Okay. So so the next step is to sort this list by propensity, right? So, and we want it in what order? Descending order, right? So descending order would be that. Okay. So now we can set up case numbers. So 882 cases. Okay. Now for us to be able to develop an ROC curve, okay, so we have to have a classification matrix, okay, so that would be based on a cutoff point that we can select. Okay. Whatever the cutoff point is, then this table should automatically update. So the event of interest is the flight is delayed. Okay. Okay. And we need actual class is number of owners, so that would be count if. This is actual, so select that, right? And let's make that absolute reference just in case. And we want delay, right? Okay, so from there you get 172. Okay, so this would be just a count of these. And that would be that minus that. Okay. Now for the column total, we do the same thing. Now this time, the same thing like the count if here, but we need to now use the predicted column. So into flight status, so that's our predicted class. So use that. And then of course the condition is still delayed. Okay, so this should be not owner, delayed and on time. All right. So then, excuse me? Oh, okay, will do. Yes. Okay. Okay. All right. So now here. I think I made a mistake, right? Because this predicted class should be based on the cutoff point, right? So the count if here should be based on propensity. So that one, right? Comma. Now this is, I forget the, this is, I think I need to have like that. Okay. So now if I change that to say 0.2, it will automatically change. And that's what we want. For us to be able to generate an ROC curve, this table should be such that it will automatically update when we change the cutoff point. And what is the cutoff point? Cutoff point is the threshold for propensity for us to classify a record as an event. So if it is 0.5, if the propensity is 0.5 or more, it will be classified as an event. If it is 0.2 and above will be classified as an event, and so on. Okay. All right. So that one is good. So next is here we need the two conditions that we have to specify. One is that the actual class is delayed and the propensity is greater than or equal to the threshold, so that the record will be classified as delayed. So you will have count if, okay, the actual class is here, okay, and that is delayed, okay, and the second one is the propensity, which is this, okay, comma, greater than or equal to ampersand done. All right, so I think the function is count ifs. Yes, I missed the yes. All right, so there you go. So that would be the actual class is delayed and the predicted class is also delayed, and we are counting the predicted class as delayed by looking at the propensity. The propensity is greater than or equal to the cutoff point. So now if I change the cutoff point, that value will automatically adjust. Okay. So now we can fill out the rest of it by simply computing the difference. So this minus that will be the false positive. So this minus that will be this is false positive, this is false negative, and then this is, oops, what did I do? That minus that. Okay. So sensitivity is that divided by that. So given the record is an event, what is the probability that you correctly predicted as an event? And specificity is the same thing for negative. So that will be, given the record is negative, what is the probability that it will be predicted as negative? So that is specificity. All right. So now we want these two numbers to be calculated for various cutoff points. So that plus 0.05, so that will give you two cutoff points. And then let's go all the way till 1. Okay. And then build our table using data table. Now the cutoff values are in a column, so cutoff values being the input values, it's in a column, it is that, and it should go into this cell. So now we have the sensitivity and specificity, and for ROC curve, 1 minus specificity goes in the x-axis and sensitivity goes in the y-axis. So let's go ahead and highlight sensitivity column and then select that scatter plot, and then click select data and edit the series, and we will enter the then minus specificity range. So that's E20 through E40. Okay. So now we have the ROC curve for the classifier. Of course, we need to connect the diagonal value for comparison. That's our baseline. So our baseline will be for x equal to 0, you have y equal to 0, x equal to 1, y equal to 1. So that would be our benchmark random classification. So highlight and select data, and you add the series with x value being that and the y series being that. So now we have the ROC curve. Okay, so this is how you generate the ROC curve. To be able to generate the ROC curve, we have to have the propensities. Without the propensities, we can. So this column is necessary. Without that, you will not be able to recalculate your classification matrix. So the classification matrix that SAS gives you in the results page, that is for 0.5 as the cutoff value. Of course, it does all the computations for ROC curve in the model comparison node. The model comparison node will do all those computations and it will give you the final result. Now, if you want to do it yourself, okay, this is how you do it. So this will be ROC curve, and of course you want to format these axes